Hi, my name is John. In this episode, I work on the pulley and get it installed on the stepper motor that I'm going to use to drive my spindle, as you can see right here. I have this new pulley that is going to go on here, so I'm going to take the current pulley off, or at least try to. Okay, it's not too bad at all. Well, that's cool. It just pulls straight off. There's a key in here. Okay, so as you can see, it doesn't fit. If I measure this bore here, it comes out to 15 millimeters, and what I have here is about a little bit less than 13 millimeters. So I'm going to need to bore this out a little bit. Now, since I don't have a lathe, I'm going to try boring this out on my milling machine with just interpolation, and I'll keep doing it until it's a nice fit here. But while I have this off, I think I'm also going to take some of the other things off. So I'm going to take this guard off because I don't really need it, but I want to keep the screws for the new motor mount that I made. This guy here. And now I've got the basic motor down. Since I've got this off, I thought I'd just try this and see how it fits. Should fit fine, but you know, it's always good to test. Yep, looks like it'll be just fine. So that will fit on my milling machine like this. Okay, next step is to come up with a plan for how I'm going to hold it and mill it, and also find the center of the hole. This is the plan that I came up with. I have a fixture which will accept some screws for tie-down clamps to hold the pulley in place while I bore it out. So the first thing I did is I downloaded a 3D model for the pulley, and then I cut a hole through it which is 15 millimeters in diameter. That's the target hole size that I want. Then what I did is I created a fixture that has a hole in it, and what I want to do is I want to mill this hole precisely to the correct size so that it's a tight fit for the pulley. So in order to do that, you can see that if I hide the pulley, first thing I did is I pocketed this out. Then I have a relief here so I can bore down below the bottom of the pulley, and I'm not going to hit this aluminum. And then we get to the interesting part. I decided to use cutter compensation, and the idea of cutter compensation is that instead of having the computer calculate where the toolpath should be, it calculates the toolpath as being the final curve that you want. And then in Mach 3, which is what I'm using to drive my milling machine, I'll tell it that the tool diameter is 0.25, and that should give me a curve right here. If the circle isn't the right size, then I'll change it to slightly less than 0.25. And what that will do is it'll cause the tool to move slightly this way and cut the circle slightly larger. Once it does that, I'll spot drill for the hold down clamps, and then once I have it all mounted, I'll bore out the center of the pulley, and then this is where I'm going to use cutter compensation again, as you can see, to slowly walk in the size of this hole till it fits just right. The way that you enable cutter compensation is by right-clicking and selecting in control. So there are several different options here. Mach 3 supports in control. In computer means that Fusion is going to calculate the correct toolpath. When you say in control, Fusion is going to emit either G41 or G42. In this case, it's G41. And it's going to tell it that it should use the tool table in the controller, which is Mach 3 in this case, instead of having Fusion 360 calculate it. So I set it to in control for both this toolpath as well as this toolpath here, as you can see. There's one more thing I had to do with the cutter compensation, and that is when you post it, which I will do here. So one of the things I like to do is name my toolpaths with the type of the cutter in it. And then when it brings up the editor, the important thing is to find G41, and you'll see G41 actually appears in several different places. We need to change that in each place. The problem is that there are two problems. One is that Mach 3 does not like G41 to be on a line with another command. So I put it on a line above that command. And then the other thing is it doesn't like this P command, because what that does is the P, I guess it's a parameter actually, is overriding the diameter, actually in this case the radius, of the tool in the tool table. So it's forcing it to 0.25. So we have to get rid of that. So I'll go ahead and find the next G41 and change that as well. So I'll go ahead and change all of these, save these out, and then we can head to the milling machine. I started to have a lot of problems with the milling. One of the things you're going to see is that it keeps diving into the material, and it drove me absolutely nuts. I was trying to figure it out. I thought maybe the problem was that the tool was being pulled out of the tool holder. That turned out not to be the case. I thought maybe it was a problem with my Z slipping down, and because of the ball screws, but that turned out not to be the case, and I finally figured it out. And the problem is that I didn't have the dovetail clamped strongly enough, and that was what was causing it to pull down. So once I fixed that, you can see that it started to work just fine, and I was able to finish the pocket. Next, I'm doing the profiling to remove the material that I left in the previous operation. And then once the profiling is finished, this is where I switch over to Mach 3 and set up the cutter compensation. There's an offset tab, and then you want to click on Save Tool Offsets. And then here you can change the number to be a smaller number in order to increase the hole size. Here I'm setting it to 0.248. And then you have to click Apply and then OK, otherwise you'll lose your changes. Here it's taking off another thousandths or so. And once it finishes this pass, then I'll see how the fit is. So after a few times around, you can see that it fits in really nicely, and there's no slop at all. There's no movement. It's really tight. I'm drilling pilot holes, and then I'm going to drill holes that I'm going to use for some 1032 screws, or 1024. That will allow me to clamp the pulley in place while I do the other operations. So I'm going to drill these all the way through and then tap them with a tap, and now you can see I can put it in place and hold this down very nicely and firmly. That way I can take the pulley out and put it back in as I adjust the bore to get it dialed in just right. Here I'm using the boring operation, which is going pretty well, at least so it seems. But what you'll see is once it gets to the end, once it gets all the way down, it retracts, and then it starts over again, and then it bites in as you're about to see, and then I need to stop it. Let's take a look at what happened here. If we look here, it's a little hard to see what's going on, but if I hide the CAD parts, you can see that there is this part here at the end of its boring all the way down that was causing the issue. And the problem there, let me turn this back on, is that I had edit finishing passes turned on, or finishing passes turned on. So when I uncheck that, you can see that the bore expands and we don't have the part at the bottom. We also don't need a repeat pass, so we'll just go ahead and repost that, and that should work just fine. I'm loading the next toolpath, which is the one that uses cutter compensation. So once the toolpath loads, I need to go over to the Offsets tab and then change the offset. And I want to start with a diameter at 0.252, which is going to give me a slightly smaller hole than I want. And then I want to dial it in a little bit at a time. Try it out every now and then keep trying until the fit is just perfect. So what you'll see here is that right now it's not quite there. I put it back in, change the number again, and then give it another try. Alright, so it just barely slips on. So I'm going to want to adjust it by less than 1/1000th this time. Then I want to make sure it's clocked the same. Okay, that's a pretty good fit. I'd say that'll work. The original pulley had a ring around here which contacts a part of the motor that rotates, and then this part here does not rotate. So I decided to mill out a small pocket to match that. If we take a look here, you can see that the Allen key is below the top of the material when it's in place. So I decided to add this little slot here that will allow me to get an Allen key in there and tighten it to ball and Allen key. So I'll go ahead and mill that right now. As you can see, the pulleys both have this little lip on it. I don't have a key slot, so I do have the set screws. So what I'm going to do is I'm going to try to put the set screw roughly where the slot is and get it close to in place. There we go. And now I'll go ahead and put this back on. Perfect. Whoops. That wasn't very good. Ha! Never had an Allen wrench break off before. That's going to be interesting. Okay, I looked in there and I couldn't figure out how to get the Allen wrench out, but what I did do is this Allen wrench still kind of works. So I was able to put it into this other one. This one here. And tighten that down. So they're both tight. Hopefully I won't have to get this off because I'm not sure how to get that out. So I'll just put it back together with okay. That turns nicely, so that should work just fine. Thank you for watching as always, and if you like this episode, please give me a thumbs up. If you didn't like the episode, give me a thumbs down. But also please, in the comments, let me know why, because I want to improve these videos. Also make sure that if you subscribe, you click on the bell so that you're notified when I have a new video. In the next episode, I'm going to be working on a speed control knob so that I can control the speed of the spindle just by turning the knob. See you next time.